Now we've used the Pythagorean theorem, we're going to play with it a little bit. So here we have an acute triangle. An acute triangle means that all the angles are less than 90 degrees, so this is an acute triangle. Here's a right triangle because it has one 90-degree angle, and here's an obtuse triangle because one of the angles is greater than 90 degrees right here. Okay, and the squares of the sides are drawn in. So you're going to fill in the chart below. So with the acute, I want you guys to add up smaller squares, so 36 plus 64, and compare it to the area of the largest square. Same thing with the right triangle and the obtuse triangle. You're going to answer, does the Pythagorean theorem work for all triangles? The answer is no. Yeah, actually, let's just do this together. Okay, so the acute, we've got 36 plus 64, which is going to give me 100. And the area of the largest square is 81. The right is 36 plus 64, which is still 100. And the area of the largest square is 100. And then the obtuse, I got 36 plus 64, which is 100. And the area is 121. So you'll notice here, with the acute, the sum, or the largest square was smaller than the sum of the two smaller squares, and with the obtuse it was larger. So no, it doesn't work for all triangles. And that is really important to remember, because I've seen many students try to use the Pythagorean theorem when you don't have a right triangle. It doesn't work. But we can use it information to determine whether or not a triangle is a right triangle. So let's look at whether each triangle with the given side lengths is a right triangle. Well, we could draw it. So we have 6 centimeters. I have no idea what this is going to look like. 6 centimeters, and 9. So 6, 6, and 9. So this would be 36. 36. And this one here, kind of off the screen, is going to be 81, but 36 plus 36 is 72. 72 does not equal 81, not a right triangle. Okay, so let's look at these here. So I would need to know if 7 squared plus 24 squared, I need to know what that is and compare it to 25 squared. Well, 7 squared is 49. 24 squared, can't think of off the top of my head, is 576. If I add 49 to that, I get 625. And 25 squared is 625. I said it was something different later. 525, and that was wrong. Please change that. So these are equal. And therefore, yes, this is a right triangle. Okay, so we can always check that we can add the squares of the two smaller numbers and compare it to the square of the biggest number. If it's the same, right triangle. Not the same, not. Even if it's close, not. Okay, so a set of 3 whole numbers that work in the Pythagorean theorem is called a Pythagorean triple. So 7, 24, 25 would be a Pythagorean triple. 6, 6, 9 would not be a Pythagorean triple. So we want to know which of the following numbers are a Pythagorean triple. So what we have to do is we have to check the two smaller numbers. We're going to add the squares together. It's 3 squared plus 4 squared. And we're going to compare that to 5 squared. So that's 9 plus 16, which is 25. 5 squared is 25. Yes, this is a Pythagorean triple. Okay, 8 squared plus 15 squared is 64 plus 225, 289. 18 squared is equal to Not 289, but let's see what it is. 324. Not a Pythagorean triple. 11, 60, and 61. So again, squares of the two smaller numbers. 11 squared plus 60 squared equals 121 plus 3600. And that's going to be 3721. 61 squared, I'm going to guess it's probably that. Yep, is 3721. So yes, this is a Pythagorean triple. So if you had a triangle with sides 11 centimeters, 60 centimeters, and 61 centimeters, it's going to have a right angle. If you have one with 8 centimeters, 15 centimeters, and 18 centimeters, it won't have a right angle. If you have one with 3, 4, and 5, it will. There is your practice. Extra challenge, and when you're done that, you have a quiz.